Alright, here is lesson 2, generating equivalent expressions, part 2. So for our opening exercise, complete the opening exercise and then check your answers by continuing the video. Okay, you should be done with the opening exercises, so let's see what you got. So if you have an expression and its opposite, then the proof of the opposites, just like in the first row, would mean that 3 plus negative 3 is equal to 0. And the opposite of the expression negative 7 means that negative 7 plus 7 equals 0. And so on and so forth, even when we talk about x and the opposite of x, or 3 times x and the opposite of 3 times x, and also 3 plus x would mean that we are taking negative x plus negative 3, and 3x minus 7 would be a negative 3x plus 7. So again, the whole idea of the opposites, and when you add these opposites, you get 0. When you add the opposites here, you also get 0. So in the last 2 rows, explain how the given expression and its opposite compare. Well, recall that the opposite of a number, say a, satisfies the equation a plus a negative a, or the opposite of a, is equal to 0. We can use this equation to recognize when 2 expressions are opposites of each other. For example, since the quantity of x plus 3 plus the quantity of negative x plus negative 3 is equal to 0, we can conclude that negative x plus negative 3 must be the opposite of x plus 3. This is because when either the opposite of x plus 3 or negative x plus negative 3 are substituted into the blank in the expression, the quantity of x plus 3 plus some expression is equal to 0, the resulting equation is true for every value of x. Therefore, the 2 expressions must be equivalent. The opposite of the quantity of x plus 3 is equal to the opposite of x plus the opposite of 3, or negative 3. So since the opposite of x is negative x and the opposite of 3 is negative 3, what can we say about the opposite of the sum of x and 3? Well, we can say that the opposite of the sum, x plus 3, is the sum of its opposites, negative x plus negative 3, or the opposite of x plus the opposite of 3. Where have we heard that before? So is this relationship also true for the last example, 3x minus 7? Well, yes, because the opposites have a sum of 0, so the quantity of 3x minus 7 plus some expression has to equal 0. If the expression is negative 3x plus 7 is substituted in the blank, the resulting equation is true for every value of x. The opposite of 3x is negative 3x, and the opposite of negative 7 is positive 7. And the sum of these opposites is negative 3x plus 7. Therefore, it is true that the opposite of the sum, 3x plus negative 7, is the sum of its opposites, negative 3x plus 7. And here we have the sum plus its opposite is equal to 0. So therefore, the opposite of the quantity of 3x plus negative 7 is equal to a negative 3x plus 7. Can we generalize a rule for the opposite of a sum? Well, sure. The opposite of a sum is the sum of its opposites, which we did last unit. We can use this property as justification for converting the opposites of sums as we work to rewrite expressions in standard form. Let's take a look at example 1. So subtract the expressions in example 1a first by changing subtraction of the expression to adding the expression's opposite. Remember, finding the opposite or inverse of an expression is just like finding the opposite of a mixed number. Remember that the opposite of a sum is equal to the sum of its opposites. So the opposite of 2 3/4 is the same as negative 2 plus negative 3/4. Therefore, the opposite of the expression 2 plus x would be a negative 2 plus a negative x. So let's look at part A, subtracting 40 plus 9 minus 30 plus 2. The opposite of a sum is the sum of the opposites. So if we take the opposite of 30 plus 2, then we would end up with 40 plus 9 plus negative 30 plus negative 2. Well, then 49 plus negative 30 plus negative 2 is 19 plus a negative 2, which is 17. Next, subtract the expressions using traditional order of operations. Does the difference yield the same number in each case? Well, yes, because using the order of operations, 40 plus 9, doing the parentheses first, would be subtracted from 30 plus 2, or 32. Well, 49 minus 32 is 17. So which of the two methods seems more efficient and why? Well, which method would have to be used in example 1b and why? Well, we have to use the opposite expression because the terms in parentheses are not like terms, so they cannot be combined as we did with the sum of numbers in example 1a. Obviously, if all we have are numbers, then we can use the order of operations. But when we have a mixture of variables and numbers, then it's probably more likely that we're going to have to deal with terms in parentheses that are not like terms. So for part B, we would have to do subtraction as adding the opposite. So again, we are subtracting this quantity of 4x plus 11, which means that we're going to end up with negative 4x plus negative 11. Also, in our first quantity, 3x plus 5y equals a negative 4, or plus a negative 4, as opposed to minus 4. Once we do that, now we can do any order, any grouping. We can combine like terms and put them next to each other. And then, combining like terms, we end up with a negative x plus 5y plus negative 15, which is also, again, subtraction, replacing the opposite, negative x plus 5y minus 15. So check the equivalency of the expressions by substituting 2 for x and 6 for y. This is what you would have. Substituting in after the first expression is given, and then using our order of operations to simplify, we get 36 minus 4 minus 19, or 32 minus 19 is 13. With our equivalent expression, we take the opposite of 2, and 5 times 6 minus 15 would give us negative 2 plus 30 plus a negative 15. Then we have 28 plus a negative 15 equals 13. So the expressions yield the same number, 13, or the same value, for when x is 2 and y is 6. When writing the difference as adding the expression's opposite in example 1b, what happens to the group terms that are being subtracted? Well, when the subtraction is changed to addition, every term in the parentheses that follows must be converted to its opposite. All right, let's take a look at example 2. We will combine expressions by vertically aligning like terms. So here's another way of combining like terms, doing it vertically. First, we start with addition as adding the opposite. Again, turning our subtraction to adding the opposite, so we have plus a negative 6c and plus a negative 4b. Now we can line up terms vertically like we do in addition problems. Put our a's together, our b's together, and our c's together, draw a line to add these, and then work vertically. 5 plus 2 is 7a, 3 plus negative 4 is negative 1b, so we drop the 1, and negative 6 and positive 13 is 7c. So our expression would be 7a minus b, because again, taking the opposite, turning addition back into subtraction, plus 7c. All right, let's do subtraction as the opposite of, or subtraction is adding the opposite. With this expression, we would have plus a negative 4. And then again, since we're subtracting this group, we end up adding the opposite of each term. So this becomes negative 5x and plus a negative 2. Aligning our like terms, we don't have any y's, so this stays blank. So we have 2x minus 5x, or 2x plus a negative 5x, and negative 4 plus negative 2. And so therefore we get negative 3x plus 3y, since we didn't add or subtract anything from it, plus negative 6. And last, turning addition back into subtraction, negative 3x plus 3y minus 6. You should recognize that the subtracted expression in example 1b did not include a term containing the variable y, so the 3y from the first grouped expression remains unchanged in the answer. All right, on to example 3. We will write an expression representing an unknown real-world value. Rewrite as an equivalent expression and use the equivalent expression to find the unknown value. So a stick is x meters long. A string is 4 times as long as the stick. For part A, express the length of the string in terms of x. Well, the length of the stick in meters is x meters, so the string is 4 times x, or 4x meters long. For part B, if the total length of the string and the stick is 15 meters long, how long is the string? Well, the length of the stick and the string together in meters can be represented by x plus 4x, or 5x. If the length of the stick and the string together is 15 meters, the length of the stick is 3 meters, and the length of the string is 12 meters. So let's go ahead and do example 4. Read the word problem about Margot and her storage unit. Let M represent the number of months that the storage unit is rented. We have the quantity as 17 times M plus 3 minus 3M plus 1. So by using subtraction as adding the opposite of the quantity 3M plus 1 becomes negative 3M plus a negative 1. So now, using any order, any grouping, we put our like terms together and our constants together. So we end up with 14M plus 2. So this means that Margot will have to pay $2 of the processing fee and $14 per month that the storage unit is used. Well, if we know that it's 6, 14 times 6 is 2, so 84 plus 2 is 86. Margot will pay $86 toward the storage unit rental for 6 months of use. All right, example 5. Why do we convert differences into sums using opposites? The commutative and associative properties do not apply to subtraction. Therefore, we convert differences to sums of opposites so that we can use any order, any grouping property with addition. We have seen that the any order, any grouping property can be used with addition or multiplication. If you consider how we extended the property to subtraction, we can use the any order, any grouping property in a division problem. Explain. Well, dividing by a number is equivalent to multiplying by the number's multiplicative inverse or reciprocal. So division can be converted to multiplication of the reciprocal, similarly to how we convert the subtraction of a number to addition using the additive inverse. So after converting a quotient to a product, use of the any order, any grouping property is allowed. Complete the table based on the first row and check your answers when you are done. All right, let's see what you got. So, given 3, the multiplicative inverse is 1/3. So 3 times 1/3 is 1. So therefore, 12 divided by 3 is the same as 12 times 1/3, which is 4. 5 becomes 1/5. 5 times 1/5 is 1. So therefore, 65 divided by 5 is the same as 65 times 1/5, which is 13. And so on with negative 2 becoming negative 1/2. Notice that 18 divided by 2, or 18 divided by negative 2 is the same as 18 times a negative 1/2. Well, that's the same as 18 times the negative 1 times 1/2. And negative 18 times 1/2 is negative 9. Going on, check the rest of your answers. If you have any questions, please write them down and bring them to class. How do we know that two numbers are multiplicative inverses or reciprocals? Well, recall that the multiplicative inverse of a number a satisfies the equation a times 1 over a equals 1. We can use this equation to recognize when two expressions are multiplicative inverses of each other. Since the reciprocal of x is 1 over x and the reciprocal of 2 is 1/2, what can we say about the reciprocal of the product x and 2? We can say that the reciprocal of the products 2x is the product of its factors' reciprocals. So 1 over x times 1 over 2 would be 1 over 2x. What is true about the signs of the reciprocals and why? Well, the signs of the reciprocals are the same because their product must be 1. This can only be obtained when two numbers of the product have the same sign. Because the reciprocal is not complicated by the signs of numbers as in opposites, we can justify converting division to multiplication of the reciprocal by simply stating multiplying by the reciprocal. All right, let's wrap this up. Why can't we use any order, any grouping directly with subtraction or with division? Subtraction and division are not commutative or associative. How can we use any order, any grouping in expressions where subtraction or division are involved? Well, subtraction can be rewritten as addition and the opposite, additive inverse, and division can be rewritten as multiplying by the reciprocal or the multiplicative inverse. All right, we'll see you in class.